And thank you everybody for being here today. I hope you're all having a good AWE so far. We are XYZ. There's a few of us in the audience here. We are the world's leading developer and provider of XR technologies for the construction site. We're based in London, but we have operations all over the world. And I believe that construction and fixing its problems is the killer app for XR, and I hope that by the end of this talk, I might have convinced one or two of you to feel the same way. Thank you. Next slide. Where's that? Is it this? Okay. Huh? Aha. Oh, how do I go back? Okay, all right, with that sorted out. A little bit about me. So I'm Mark. I've been working in the immersive sector for about 11 years now. I started out doing 3D body scanning applications, and I've done a PhD in mechanical engineering for wearable health technology at UCL. And I was last at AWE back in 2018 with the WeKit project, which was a HoloLens industrial training platform which I supervised in hundreds of industrial trials, training people how to do things like maintain and repair the air ambulances up in the Arctic Circle, and we used it for training astronauts in Turin at Altec. And the successor of that WeKit project is actually on display at the exhibitor hall today, so I'd urge you to go and check that out at the XR2 Learn area. Still a really cool project, they're doing great things. However, of course, now I'm the head of spatial computing at XYZ Reality, and I've been here for 4 years. I joined when it was just a tiny team of 20 people with only a rough prototype, and I've helped it grow into what I'm going to show you today. All right, let's talk about construction. So it's a multi-trillion-dollar industry with multi-trillion-dollar problems. Unfortunately, it's just an unfortunate fact of life that mistakes happen, and pretty much every project from the airport that I flew here from to my grandmother's loft extension, they inevitably run into problems, and they go over budget, and they fall behind schedule. This is kind of just a law of nature, or so it was until today. And why does this happen? Well, one of the main reasons is that 30% of the work that is done on a construction site is in fact rework. So that's fixing mistakes that have been made. So 30% of all the activity is just fixing mistakes. Our founder and CEO, David Mitchell, he's been in construction for his whole life, and he's seen a lot of these problems firsthand. And in 2017, he founded XYZ after learning about AR technologies. And he realized that it could be the killer use case. So by law in Europe, all large-scale construction projects, they're designed according to BIM standards, that's building information modeling. And what does this mean? It means that you have to have a very detailed and high-accuracy model during the planning stage. However, when it comes to translating this out onto the building site, quite often the plan kind of goes out the window, and there's things that people hadn't accounted for, and so on. And so that is one of the biggest problems as far as we've identified. And by showing people holograms of what they're building positioned within construction tolerances, the industry could finally be able to build things right the first time and on time. All right, next one. So back in the early days of XYZ, we tested out all the existing solutions that were out there, and we found that they just weren't up to the job for what we wanted to do. Construction models can be really big. You know, some of the data centers that we've worked on, they're like over 1 kilometer long. They've got hundreds of thousands of elements. They've got hundreds of millions of polygons to be rendered. They're just huge. And the existing products out there, they weren't even able to store this data on their disk, let alone render it in real time. And you might be asking, oh, why don't we just use render streaming to stream it from somewhere else? Unfortunately, on a lot of construction sites, you don't have Wi-Fi, and you don't even have 5G if it's in a remote area. And if it's indoors, then that rules out things like Starlink a lot of the time. So we had to design something that can run offline. And the workflow being, you go in the office at the start of the day, you sync all the data for the day, you go to the site, do your work, and it's all offline. And then at the end of the day, you sync it back to the cloud again. So that's our workflow there, and we found that our devices weren't powerful enough. Also, they weren't accurate enough. You would find that if you, say, walk around in a circle and you come back to exactly where you started from, the system's tracking technology will have drifted a little bit. You have an accumulative drift that can build up over time with a lot of these tracking technologies. And construction typically permits a sub 10 millimeter tolerance for errors, and there was no device out there that was able to meet this standard. And finally, there were really strict rules as to what you can bring onto a construction site. So if anything you're wearing on your face, you need to have unobstructed peripheral vision to be able to see any kind of threats and obstacles coming in from the sides. Anything that's covering your eyes has to have an optical clarity index test. So that rules out pass-through devices like the Vision Pro. There's a bunch of reasons why we had to do what I'm going to show you next. We realized that we were going to have to do it the hard way, and we built the Atom right here. So this is the only AR headset that's been purpose-built specifically for construction. It's a fully safety certified hard hat. It's got an Intel i7, 32 gigs of RAM, and a terabyte of SSD storage. So it's effectively like a reasonably powerful laptop that's all been reconstituted into the form factor of a hat. It's also got hot swappable batteries so that you can have uninterrupted power throughout the day. And it's got a set of cameras on it. It's got some tracking cameras. It's got a laser tracking system. And it's also got an RGB camera so that you can capture composites of holograms and reality. So it's not just the Atom. We've also built our own file format and exporters for various things like Revit and Navisworks. So once you've done your modeling, you can just drag and drop the model into our web platform. And we'll convert it into our .xyz format and sync it onto your device. And this is a file format that's been designed to efficiently store and transmit BIM models and then be able to load them really efficiently into the GPU for real-time rendering. It also comes with a controller. So why do we use a controller? I know that the hand tracking is really in vogue at the moment. There's a couple of reasons. So often on a construction site, people are wearing gloves, and they can be really thick. And a lot of the hand tracking models that we looked at, they've not been fine-tuned for working with gloves. So that's a big problem. Another one is that often on a site, people are going to be communicating to each other with hand gestures, and we don't want them to get misconstrued with people interacting with the technology. All right, so we built this controller. It uses the same millimeter accurate tracking system as the hard hat, and it has a really fine steel tip on the end of it. So we can track the pointer tip down to millimeter accuracy, and we can use that to sample points around the site. And this has a number of uses. We've got like a tape measure tool, so you can measure from point to point. It's the only tape measure I've seen that can actually measure through solid objects because it's effectively measuring in air. And you can also use it to sample points around the site and align your models. So what you're seeing the engineer doing in this image is he's using the controller to sample the position of a survey point. These survey points, they get put down by surveyors. They put thousands of them across a building site, typically. And each of these points, it represents a 3D coordinate relative to the site's coordinate system, so relative to the models. So what you can do with the Atom and the controller, you can go around and tag any 3 points, and you can use that to be able to align the models to the environment with a really, really high accuracy. We offer some other methods as well. If there aren't enough points available in an area, then you can align using flat surfaces. So you can tag a flat surface in the model and then go and tag the same one in the environment, and we can align that way. However, using control points is still the gold standard for getting a really accurate alignment here. Okay, I think it's time to see some videos of all this in action. So here we go. Here is a quick 30-second compilation of the Atom in action on numerous mission-critical infrastructure sites around the world. The majority of our clients so far, they've been data centers, but we've also expanded out into pharmaceuticals and aerospace. And you can see that, yeah, as well as the see-through AR, we've also got the camera, which is able to capture videos like you're seeing here. And in the final clip that's coming up after this, I like this one because it makes it super clear what the value proposition is right here. You can very, very easily see the difference between the hologram, the as designed, and the reality, the as built. It becomes immediately obvious when something has not been done correctly. Okay. So what did we just see there? The Atom accelerates your construction projects by providing real-time evidence and insight into these 3 critical data realms. The first one is progress. So up until recently, you'd kind of have to rely on somebody's estimate that, this part of this project is now 90% complete, when the reality is it might actually only be 20%. That's not a figure I've made up. That's a real scenario that we've found out in the wild. And what you can do with the Atom instead is you can go around and you can say, all right, I'm in this room, show me all the elements that should be installed by this particular day, and it will show them, and you can say, hey, there's a hologram there, but there's no real-world counterpart, so that part is late. You can tag it, and it will then get synced up to the cloud. And then similarly, you can say, hey, look, there's a hologram, and there's the part that has been done on time. So really simple mechanic there, but it's incredibly powerful, which you'll see in the next slide when we show you how that works in our platform. We also offer quality data, so typically the workflow has been, you complete the work, you take a laser scan of the area, you send it off to a remote office, they will align the scan over the models, and then they go through it and they look for any discrepancies and say, hey, there's a clash here, that kind of thing. The workflow for that can take weeks, and whereas what we're doing with the Atom is we're able to make these quality observations and get you that data in real time. And finally, there's cost. So yeah, obviously tracking cost is super important here. And what we do is we take all of the previous data, we combine it with some proven models, and we're able to predict just how much the knock-on effect of various mistakes is going to have on the overall cost of your project. All right, so all this data then gets synced up into our platform, which you're going to see a video of now. Here we go. So this is a web platform right here. You go on the website and you get a 4D BIM viewer, so you can view the entire site model over time. You can look at a bunch of, what are they called, dashboards, which will show you, say, the predicted status of the project at a certain time versus the actual observed status of the project over time. And often they're glaringly different to what people thought they'd be. You can also, you'll see in this next bit, we color code everything. So all of the elements that have been flagged as red, they're currently late, and all the ones that have been verified as installed on time, they're shown in green. So it becomes really, really easy to just see, okay, this bit of the project's behind schedule. This room of the project is behind schedule. The electronics are behind schedule, or even everything that this one particular team worked on is going behind schedule. And this then allows the client, the asset owner, to be able to take action and prevent these things from getting even worse. This is an example of the issues dashboard. So all the issues that have been raised in the Atom, you're able to see them in the context of the complete model. And I'm able to click on one, and then I can see all the evidence that was gathered using the Atom. So all the pictures, videos, things like who it's been assigned to, what date action is due by, what recommended actions need to be taken. And this is a new feature that I'm really excited to share with you today. This is 360 capture. So an engineer can go around the site, go into a room, and snap a 360, just to give you a really clear picture of how the site is right now. And you can do them on different dates and view them side by side, so you get an instant idea of exactly how the project is progressing over time. All right, with that done, let's move on to some case studies. Here's the first one. So this first case study shows every structural guy's nightmare. This is from one of the first projects that we were deployed on years ago. This was a hyperscale data center out in Denmark. And what happened here is someone got the dimensions wrong. All right, you can see that in the top right image over there. The hologram's showing the height of the concrete foundation, and what they've actually poured is extending up quite a bit higher than it should have been. And because we'd only just arrived on site, they'd done this without getting the Atom involved for the pre-pour inspection. But fortunately, we were able to come along and catch it before it was too late, and they were able to remedy that in the design. And so that was an instant saving of $31,000, 3 weeks to the program. And then the knock-on effects of that add up to $110,000. So yeah, we proved ourselves in that first observation. That's just a single observation that's able to save all that money and time. Unfortunately, after that, they said, oh, wow, this is valuable. And they made sure that we were getting involved in all of the pre-inspections after that, and it really helped bring the project back on track. Okay. Next one. Okay, so this one is it's called a bus bar duct installation. And this one was right on the critical path. So anything going wrong here ends up being really, really expensive. And what we found is that there were some steel rods coming down from the ceiling, which were not in the model. All right, you can see that there's no hologram there. And when we went and gave an inspection of the area, we were able to see, one of these elements that you've planned to install in the near future is actually going to clash with these things that weren't accounted for in the modeling system. So we were able to flag this up several weeks ahead of schedule, and the client was able to take action on this. They were able to procure the additional design parts and work around the issue. And this is great because, this is the beauty of the Atom. We're able to spot these things and forecast issues long before they actually happen and allow people to take corrective action ahead of time. If we were not involved here, if they weren't using the Atom, then what would have happened is the contractors would have come to the site, they would have begun the installation, they would have gone, oh God, there's a clash, and then they would have had to down their tools, go to the office, and initiate a lot of arguments with people across the whole supply chain to try and figure out what's gone wrong here. But instead, we were able to stop all of these issues from happening before they even happened. Okay, in this third case study, this is about underground services. Any mistake you make with underground surfaces, it typically gets buried under your concrete, and then it comes and bites you in the arse later down the line. Obviously, concrete is one of the world's worst offenders for carbon emissions as well. So if you pour a whole site with concrete and then you have to break it all up and start again, that's really, really not good for a building's carbon footprint. So if you can catch these things and prevent that, that's really, really wonderful. So what we can see here is that the manhole in the top image has not been installed correctly. And this is just one instance, but there are actually 15 instances that we found around the whole site where the manhole was misaligned by half a meter or more. So yeah, pretty serious problem. And it's even more serious, in fact, because all the elements that go on top of them afterwards, they're precast, so the whole thing's supposed to fit together like a puzzle. So if something gets wrong, then you have to, and it's all buried, you either have to smash it up and start again, or you have to go and redesign and recast all of the elements that are going to connect on the top. Fortunately, we were able to catch that before the concrete was poured, and it was fixed. All right, this is the final case study that I've got to show you here. So this is always a critical one. This is a pre-pour inspection of a room in a data center. And this one was honestly a disaster because these are just two photos, but all of the embedded junction boxes and conduits were not installed correctly. And they were about to go and pour concrete on top of it and then eventually put the final flooring on top of it. And then finally after that, you might notice, hey, we've put all of the conduits in the wrong place. By that point, it would have been really late. They would have had to break up all of the flooring and the concrete, start again, and all the dust that would have created would have caused total havoc for a data center that needs to be immaculately clean on the inside. So huge win for the client there. All right, I'm nearing the end, so I've got a few final stats to summarize this all for you. Over the years that we've been working with our clients, we've managed to deliver them a 9 times return on investment for building data centers. One of our clients has been in the data center game for over 20 years, and they told us they used the Atom from start to finish on one of these projects, and they said this is the first time in our whole history that we've actually delivered a project on time. And if you remember back in one of the first slides, I told you that rework has been found to account for about 30% of activities in a construction project. And on the ones that have used the Atom, we found that we've been able to get that down to under 1%. So yeah, really powerful. As I said, I think it's the killer use case for XR, and I hope after showing you this, some of you are going to agree with me. So thank you very much. Really appreciate your coming here and listening. Feel free to check us out, get a case study, and please do connect with me on LinkedIn. I've really enjoyed telling you this. Thank you.